Okay, today we're going to talk a little bit about just graphing to start with, naming quadrant each point's in. So I'm going to put some points on here, and we're going to think about what quadrant they're in. Let's just call that point A. Go ahead and put them all on here before we start asking. Call that point B. And that point C. So, what quadrant is point A in? That would be Roman numeral 1, because remember, quadrants start right here. What quadrant is point B in? Well, they do start here, but remember they go in counterclockwise. So this would be quadrant 2, this would be quadrant 3, this would be quadrant 4, which remember is IV. So B would be in quadrant 3. What quadrant is C in? Quadrant 2. What quadrant is this point in? Well, it's not in a quadrant because it's on an axis, so that's going to be important to remember. Now, we're going to need these ordered pairs for the next slide. So what are the coordinates of A? So how many over is it? It's 1, and then it's 2 up, so it's the ordered pair 1, 2. What are the coordinates of B? Well, it's left 1, that would be -1, and down 3, so it would be -1, -3. What are the coordinates of C? It is left 3 and up 1, so it's -3, +1. So that's really what it's going to ask us to do in the next direction. So I'll just transfer these numbers over there when we get there. Write the relation as a set of ordered pairs. So really the answer to number 1 I'm going to write down here would be the set containing those ordered pairs we just did. So 1, 2, -1, -3, and -3, 1. So that is the set containing. State the domain and the range. Well, the domain is going to be the set containing the first coordinates. 1, -1, and -3. The range is going to be the set of second coordinates. So the y coordinates right there. 2, -3, 1. Now, if I would have added another ordered pair to this, let's say -1, 4, I see -1 here. I do not repeat that in the domain, or you don't repeat them in the range. So you only write them down one time. And then the third thing it asks me to do is state the inverse. Well, the inverse is pretty easy. You just take the ordered pair and you reverse them. So instead of being 1, 2, it's going to become the ordered pair 2, 1. This one will become -3, -1, and this will become 1, -3. Pretty easy things to do there, but you got to know what the definitions of these words mean in order to do it. So make sure you know domain, range, inverse, and then what a relation is a set of ordered pairs. Okay, this one asks us to solve. Again, we've done this in another review day, but we're given the domain and we want to solve. So it's going to be a set of ordered pairs just like we did, but we can put it in an XY table if we want to. Notice the y is by itself, so that's good because I don't have to do any extra work. So I'm just going to make my XY table. -2, 0, and 1 go on here. So if I put a -2 in there, 2 times -2 is -4, -2, plus negative would be -6. If I put a 0 in there, 2 times 0, -2 would be -2. Put a 1 in there, 2 times 1 is 2, 2 minus 2 is 0. So these would be my ordered pair answers. Is this a linear equation? So we look at it and see if it looks like, well, we have a little problem here because it's x times y, so it automatically tells me it is a no. And I don't have to do any more when it's a no. Didn't even ask me to put it in standard form anyway. Okay, here again it asked me to graph, so remember number 6 is a special situation because one of the variables is missing. So you don't necessarily have to make a table if you know what it's going to look like, but y is always going to be 2. So where is y going to be 2? Y is going down. So anywhere right along here, y is going to be 2, isn't it? So we draw our line through there, and that would be number 6. Now to do problem 7, we first need to get it in the right form, so I'm going to need to subtract 2x from each side. Get 3y equals 6 minus 2x. Divide by 3. And I get y equals 6 minus 2x all over 3. So it looks like I'm going to have to pay attention to what I choose here so I don't get a fraction. So if I choose a 0, 2 times 0 is 0, 6 minus 0 is 6, 6 divided by 3 is 2. So that was a good choice. Now since I'm dividing by 3's and 0 gave me a whole number, I need to go by multiples of 3. So if I add 3 onto 0, 3 would be another good choice. 2 times 3 is 6. 6 minus 6 is 0. 0 divided by 3 is 0. So what would be my next good choice? Either to go down to negative 3 or to add 3 and try a 6. 2 times 6 is 12. 6 minus 12 is negative 6. Divided by 3 would be negative 2. So 0, 2, right there, 3, 0, and then 6, negative 2, right here, run into my other line. That would be number 7. Here again we're given a function and we're asked to find g of negative 2. So anywhere there's an x, we're going to replace it with a negative 2. So g of negative 2 equals 3 times, there's an x, I'm going to replace it with a negative 2. Now I have to use my order of operation. I do powers first. Negative 2 squared means negative 2 times negative 2, so that would be 4. 3 times 4 is 12. 12 minus 2 is 10. So I would end up with 10 for that one.